Hello, is anyone there?
Yes, ma'am.
Okay, okay, I'm sharing my screen. My screen is visible? Hello, is
Ma'am.
is my screen is visible?
No, ma'am. No, ma'am.
Let's wait 2-3 minutes. Others to come. Have you revised the earlier notes we have discussed so far? Please go through. After this is the last topic we'll discuss now in this regard. Then I'll share notes by today itself. Is my screen is visible now? Hello?
Yes, ma'am.
Okay. How many students came? 39. Perfect. We can start. So what was the last topic we discussed? Anyone remember? Last topic what we discussed? We did this numerical, right? Everyone clear with this numerical? Respond. If you don't respond, I won't give class impression marks. Those who will respond, I'll give marks to them under that category. You have class impression marks, right? You know about that, right?
Yes, ma'am.
So this numerical part is clear? Yes, ma'am. Okay.
Ma'am.
Okay. Then we'll discuss about this yield stress. Should I start with here this topic? Please respond. Should I start with this topic? I gave you this numerical, right?
Yes, ma'am.
What is the approximate 0.2% offset yield stress to find out? Is it or not? Shall I discuss with this? Shall I discuss with this topic yield stress? Yield point. What is offset yield stress?
Ma'am, voice is not clear.
Hello. Now it is okay.
Hello. Hello.
Yes. Now it is
Yes,
okay.
ma'am. Yeah, ma'am.
Okay. Perfect. So I'll start with this yield stress. Okay. So basically, see if you we earlier we discussed we did a numerical based on this steel stress and strain diagram for this steel, then stress and strain diagram for this aluminium, and then stress and strain diagram for this magnesium. We have three stress and strain diagram, right? So see if for this steel stress and strain diagram you have perfect yield stress, you can say that this one is there. If you mark in this graph, if we see this graph, see yield stress is perfectly defined for the case of steel, right? But if you notice the aluminium curve and if you notice the magnesium curve, your yield stress is not perfectly defined, right? At which point you will take a yield stress? You This is not perfectly defined for these two cases. So what we do in that case is we generally assume 0.2%. Okay, we generally considered what we do. If you see a curve, it is going from here to upward direction. Okay, so if you take, let me note, my screen is visible, right? My screen is visible and my cursor is moving. Are you able to see? Hello? Someone please respond.
Yes, ma'am.
Okay.
Ma'am.
Okay, thank you. So this is your curve, it is going upward direction. Okay, so you don't know where to you have to take a yield stress. So what you generally do, you'll take 0.2%, 0.2% or 0.2% of strain. Okay, you'll draw a parallel line to this line, and the point where it will intersect, corresponding to that you will take offset yield stress. Suppose okay, basically your yield stress is nothing but lowest stress that produces permanent deformation. And if the point of yielding is difficult to identify, you typically what you do, you took a point to the percent of strain of that curve, and you draw a parallel line to that curve. The point where it get intersect, along corresponding to that value, you used to take offset yield stress. It will be more clear if you do this numerical. What is asking in this numerical? They are asking what is the approximate 0.2% offset yield stress for aluminium. Okay, they have asked you for aluminium. So which one is our aluminium? This one is our aluminium. So can you tell me by looking at the diagram, graph, can you tell me what will be the yield stress for this aluminium? Anyone? Can you see the diagram and respond to me? Which one will be the what will be the yield 0.2% offset yield stress for aluminium? Just a guess. If your network is poor, write your answer in the chat box also. What will be the answer? Respond. By seeing this, curve.
Actually, we are. Hello, ma'am.
Yes, yes.
Ma'am, actually, ma'am, we can't see your graph or the diagram.
Graph is not visible. Some of them replied 300,
Yeah, ma'am.
300. Graph is visible? Graph is visible? Only Hania facing the problem, or what about others? Are you able to see my graph where I have put the question what is the approximate 0.2% offset yield stress for aluminium? Okay, okay, 300, 310, 250, good, responded good. What about others? 30, how many members joined the class? 43 are there, only 2, 3 are answering. You should respond the answer. My screen is visible or not? I've shown the graph. 250, 250 visible. Okay, thank you. Suraj 250. Okay. Hanya, it is visible now. Likha, are you there?
Ma'am.
Okay. So
Yes, ma'am.
yes, yes. So answer will be your 310. Why? See, if you see, suppose this is 0.01, this is 5. So it must be 0.02 is this one. So if you draw a parallel line to this, right? Then if you corresponding to this, so it will be approximately 310. So your answer is 310 and your unit will be 310 MPa. Okay, so I think this part is clear to you all, that 0.2 offset yield stress. Good, responded. Next, we'll go to the topic strain hardening and permanent strain. So basically, what is strain hardening and permanent stress? Earlier we discussed this part, right? What is 0.2% offset yield stress? Then basically what is your strain hardening? It is nothing but increase in yield stress of a material by plastic deformation or permanent deformation. Strain hardening is also called as work hardening. Okay, so it is what we do. Suppose this is our stress. Suppose I'm applying a load on this member. Let me apply a load. Let me allow some students. They are in the waiting section. Okay, suppose there is a material. I'm annoting. Okay, I'm so suppose there is a material. I'm stretching it out. And I have noticed that at point one, this is your point one. At point one, it starts yielding. Okay, then again I have stretched it out to a point. Suppose two. Then I have unloaded it. I have removed the stress. Then it comes to, after unloading, it comes to this position. Earlier the position was 0, but it has shown a certain amount of deformation. Okay, let me explain once more. I have taken a material. Okay, I have taken a material and I have applied a load. When I was applying a load at one point, it starts yielding. Okay, so then I move forward at some distance, suppose 2, and I have relieved the stress. When I relieve the stress, it comes back to its position, but not original position. It has deformed. So this is the strain it has got. But again when I load, it doesn't yield at 1. It starts yielding at point 2. So what we have done, we have increased the yield stress from point 1 to the point 2. So that is nothing but your strain hardening. Okay, understood or not? That is what it is, your strain hardening. What we have done, we have increased the yield stress. Earlier yield stress was at point 1, but now we have shifted the yield stress to a point 2. So what we have done, we have increased its yield stress for a plastic permanent deformation. Earlier point was here, we have stretched it out. Then we saw that your yield stress starts at point 1, and we move forward to a point 2, and we have released the stress, and we saw that it got deflected already to this point. Again we loaded the same member. Then we saw that your yielding starts not at the one point, but your yield stress has changed. If earlier yield stress was 250, now if you stretch that member, your yield stress comes to a point of 350. So what we have done, we have increased the yield stress from 250 to 350. So we have increased the yield stress. So that phenomena is nothing but it is called as strain hardening. Okay, next, now we'll see what is Poisson's ratio. We'll define and calculate. Okay, so basically, please stop me if my cursor and you don't see my screen. Okay, so many are in waiting list, waiting lobby. Okay, let me admit them. Okay, suppose earlier I have given you an example, right? That if you stretch a rubber, then suppose the rubber was in this shape, or rubber or any material. Suppose this was in this shape. If you stretch it out, if you pull it out, then its dimension changes, right? Earlier the area was this much. Now earlier this was the width. Now your width has decreased to this. That was the original width. This is the new width when you pulled out. Okay, when you put a load, this load is type of uniaxial. So this is when you applied a load in the form of tension, and this will be the situation when you give a compress. When you compress a material, what happens? It gets compressed, and earlier this was the width. Now your original width becomes like this. So in compression your area becomes more, and in tension your area becomes less. Okay, so what is Poisson's ratio actually? Poisson's ratio is the ratio of lateral strain by longitudinal strain. Now what is lateral strain? So as you know, your strain is change in dimension by original dimension, right? So lateral means change in dimension in lateral direction by its original lateral dimension. So here your lateral I'm taking as width. Okay, you can take height also. Suppose you have a box like this. 1 second. My drawing is very poor, just adjust with that. Sorry. Suppose you have a box like this. Okay. This is your width, this is your L, and this is your height. So in the lateral dimension, you can take W or H, height. And in the longitudinal direction, you have to take the length. So in the lateral dimension, whatever be the change in the lateral dimension, either width or height, divided by its original width or height. That will be your lateral strain. Strain you familiar with change in dimension by original dimension. Now I have added a point lateral. So lateral will be your change in dimension in the lateral direction divided by original dimension. Next, it is represented by epsilon dash. Next, we have longitudinal strain. So change in strain in longitudinal direction divided by its original longitudinal direction, which is L naught. Okay. Now the Poisson's ratio we have negative of strain epsilon dash divided by epsilon. Okay. So your Poisson's ratio is what? It is the ratio of lateral strain by longitudinal strain with a negative sign. Clear this part? This part is clear? Hello? Hello? Am I audible?
Hello.
This part is clear? What is Poisson's ratio? Okay. Okay. Perfect. So we have two terms, homogeneous and isotropic. Homogeneous means your it will be the same material throughout. Okay. If it is rubber, so it will be of rubber throughout the material. Then we have considered it is isotropic. Tash 101 roll number, please mute yourself. Roll number 101, please mute yourself. Okay. Next we have isotropic. Isotropic means same material properties in all direction. All the in all the direction x, y, z, your material property. If it is in your material property will be same. Okay. So let's do a numerical. You have been given a structure member. GTCRC is tested. It is made out of a rectangular steel alloy. The length is 2 meters. Let me draw a figure, then it will be more clear. Again, suppose this is your rectangular. Your length is given to you. How much length is given to you? 2 meter. Okay. Then the cross section is 25 mm by 50. So which 25 mm by 50? Which one will be width? Which one will be height? Tell me, which one will be the cross section is given to you 25 mm by 50 mm. Which one will be width? Which one will be height? So this is width is 25, this height is 50. Okay. So this is the member, rectangular member is given to you. Length is given 2 meters, width is 25, height will be 50 mm. Then it is subjected to a tensile force of 40 kilonewton. It is subject to a tensile force. Okay. The test section elongates to 2 mm. So del L is given to you, right? First of all, write all the given. Del L is given to you 2 mm. The width narrows by 0.004 mm. The width will be that change in direction. Del L. Del lateral is given to you, that is 0.014 mm. Okay. Am I getting okay? So this I have made one mistake. Your width will be 50. If this is a member, this is 2 meter, or you can say 2000 mm. This is 50, this is 25. Okay, make a correction. This will be 2 meter long section and your width will be 50 and your height will be 25. So they have asked you to find a Poisson's ratio. Can anyone solve this numerical? Can tell me the answer? Try it. First write all the given to you. All the values given to you, right, in your copy, that it elongates 2 mm, that is del L. Del L is given to you 2 mm and its original length was how much? 2 meter. So you will find the longitude. First find the longitudinal strain, that is sigma epsilon. Epsilon was how much? Del L. Del L is how much? Elongates 2 mm. So 2 mm divided by original dimension, right? So original dimension was how much length? It is 2 meter, or you can write 2000 meter. So you will get a strain value. Then you need to find lateral strain, that is epsilon dash. So del L is given to you how much? 0.014. 0.014 divided by actual width is how much? 50 mm. It will be 50. We'll find a value. Then find a Poisson's ratio. Nu equals to minus, put this value and find out. Everyone find out and tell me the answer. Question is clear to you or not? Question is clear? Take a screenshot. Am I audible? Hello? Am I okay. Find out this Poisson's ratio. Find out the Poisson's ratio. All the data is given to you. You have to just put in the formula and find out. Got any answer? Response. Able to do. If someone haven't understood uh, anything, any given point, then please share. Then I'll again explain what are the things are given to you. What is the formula? I have wrote the formula, all the formulas above. Just you have to simply put the values in the formula. Zero point 0.007. Arif replied. Good, Arif. You replied. You did the numerical good. What about others? 48 students are here. Only few are. Only Arif responded. What about others? Right. So always sit with pen, paper, and calculator. Dash 0.7. Okay. Any other? Only 2%? Arif and Tash did the numerical. What about others? What they are doing? Point 0.28. Yes, Rupa, Ruposhri, good. What about others? Ruposhri is correct. What about others? "48 students, only 3 replied. What about others? Only 3. Hello, good. Good, hello. Rishita, hello, replied. Jamir, 0.27. You're just writing like that or you're calculating? Maintain a copy, okay? Maintain a copy, otherwise your notes will get mixed up. Good, good, good. So yes, your answer is 0.28. Okay, and there will be a unit less. I guess some of you haven't considered this minus sign. Okay, and considered the sign convention for this tensile force also. You have to consider the both sign convention. Okay. Okay. Now let's move to now let's proceed now with the part 2, which is to find new height of the cross section. You have to find the new height of the cross section. Okay. So we found Poisson's ratio based on what happened to the width and the length. So now let us use the information given to find the change in height. You have to find the new height. So for the new height, you will need change in height, right? So the Poisson's ratio here is found to be, let me note. So now you have found out your Poisson's ratio as how much? 0.28. Your new will be 0.28. Now you have been asked to find change new in height. So I told you that your lateral dimension will consider of your width and change in dimension. Basically, you have to find this value, delta lateral. You have to find this lateral value. Okay, and W naught is given to you. V equals to epsilon by epsilon. So nu equals to, let me cancel this part. My cursor is not moving now. Sometimes network gets, so let me know. Now it is moving?
Ma'am.
No, ma'am. Okay.
No, ma'am.
Just wait for 2-3 minutes. Now I have written new. Are you able to see? They have written new 0.28. It is visible now?
No, ma'am. No, ma'am.
Let me change my position once again, ma'am. Try the second part. Try the second part. Till then, you have to find the new change in height. Hello? Now it is visible? Cursor is moving? Please respond.
Ma'am.
Write in the chat box. That will be easy for me. No. No. Okay. Let's wait for 2-3 minutes. Till then, you just listen. See, try by yourself that you have to find a new height. My voice is clear, na? My cursor is not moving, but my voice is clear, right? So you have to find new height of the cross section. Okay, you have to find the new height of the cross section. How will you find? You have to find nothing but del lateral. Okay, Poisson's ratio you have find out 0.28, then that will be equals to your lateral strain by longitudinal strain. In the longitudinal strain you have all the value, change in L, original L, and in the lateral formula you have to find the del lateral divided by original height. Original height is given to you, that was 25 mm, and you have to find the del L. Will you able to find out? Now my cursor is moving. I have wrote new equals to 0.28. What is the value of L? L has value of this 2 meter, or you can write 2000 meter. L has value of, okay, my cursor is not moving, fine, but what I have told you, just listen to that, okay? You have try this, the second part. You have to find the new height of the cross section. Earlier height was given to you 25 25 mm, right? You have to find how much change in height has happened. So you have the new value which is w equals to 0.28. Let me share once again. I think then I will able to. Let me share once again. Now my cursor is moving. I have wrote new. Wait. My cursor is moving. Please respond. Okay, thank you. So we have new equals to 0.28. Okay. So what is new? New is your late epsilon naught by your epsilon. So in epsilon naught you have delta L by original H divided by delta longitudinal direction divided by original L. Okay, from this you have a value of H which is height 25 meter. 25 meter divided by, you don't know this value, so I'm taking as delta lateral itself. Okay, divided by del L. You have change in dimension, that was 2 mm. 2 mm divided by original L was your 2 meter. So it will be 2000 mm. Now new, in place of new you can write 0.28. So you have 0.28 equals to del lateral divided by 25 divided by 2 by 2000. From here you will calculate del L, right? Tell me the answer. Understood or not this part? What you have to find and how will you find? You have been given a nu, which is you have found out nu from the first part that your nu is 0.28. Now you have been asked to new height. Okay, how will you find out new height? You know the original height was 25. To know the new height, you need to know what change has been occurred to the new height, right? When you get the change in height, then that value you can add to 25 and get the new height. Okay, now find out. Now find out. Fast, fast. Be fast. Original height was 25 millimeter. Are you able to do that? Very easy. Nothing to do much. From the next class, we'll discuss deformation, strain, analysis of trusses. So I would like to go all. I would like to all of you that you go through analysis of stress. In these classes, we have just studied on what based means material property based on what factors. Okay, in to know the material properties, you should know what is the stress strain diagram, nominal stress, strain. Okay, then we'll move to next topic, which is analysis of truss. So before coming to the class, go through once. Hope you have got about truss in your engineering mechanics. So anyone find out any answer? Just tell me the del literal. You have been given new, or you have found out the new from the first. Only 2 3 are responding. Okay, rest of are not responding. You won't get marks in the category of class impression. And one information I would like to share you that the notice which was came for special exam has been cancelled, and you'll get a new notification very soon. So don't get tensed. Those who got back, you can appear for special exam and new notice will come out. And those who have not joined the group of mechanics of material, please join so that you can get a info of the class. Some of texting me, are you taking class now? Okay, ma'am, thanks for the information. Okay, tell me the answer. Sira, tell me the answer. I've given you information, now tell me the answer. No one is able to do that. Anyone? Any answer? "48 students. Not a single answer. What happened to you all? Are you facing any issue? Just share with me so that I can explain you once more. If you haven't understood the numerical, share with me. I'll share the procedure how to do that. Confused. Can you please explain it once more? Okay. What are the answers? The formula. Formula is present in front of you. Okay, let me explain once more. First part is clear? First part is clear. First part is clear. First part is also not clear. Okay. Okay, let me explain once again. So, what a question is given to you? Question is given to you that you have given a rectangular steel alloy which has length of 2 meter. So this is your rectangular section. Okay, this is your rectangular. My cursor is moving, right? My cursor is moving perfectly.
Yes, ma'am.
Okay. So this is the structural member I have been given. We have been given. Its length is given as 2 meter. Its length is 2 meter. Okay, this is 2 meter. Length is given is 2 meter. My meeting will end in 5 minutes, so I would like all of you to write your roll number in the chat box. I'll explain the this, but before that, write your roll numbers in the chat box. Don't leave the class because you will be eliminated from the participant list. So I won't be able to track your attendance. Hope everyone wrote their roll number. Okay, thank you. So see, shortly I'll discuss this numerical. Okay, my screen is visible, I guess. So try this in your home. So you have been given a rectangular section. Okay, the length of the section was 2 meter. That is your original L. L is given to you 2 meter. So in term, all the values are in mm. So you need to convert this meter to mm. So it will be 2000 mm. Clear? And they said the cross section is 25 mm by 50 mm. Your 50 mm is your width. Your original width is given to you as 50 mm. And original height is given to you 25 mm. Write this given values. Okay. They said the test section elongates 2 mm. That is del L. Del longitudinal. I'm writing del long is 2 mm. That is this value. Del longitudinal is given as 2 mm. The width narrows by this. Your width also reduced. Your width, earlier the width was 50 mm. Now your delta W will be, it is reduced by how much? 0.014. 0.014. So what you have to find? You have to find Poisson's ratio. So what is Poisson's ratio? First you have to find the lateral strain. Lateral strain is what? Del L by W naught. So del L is how much? This 0. So it will be 0.014 by 50. You got lateral strain, then you have to find the longitudinal strain. Del L by original length. Del L is how much? 2. 2 by 2000 mm. You will get longitudinal strain. And what is Poisson's ratio? It is negative of epsilon by epsilon. So minus whatever you get the value of epsilon, put the value of epsilon here. Divided by epsilon, you will get a Poisson's ratio of 0.2 meter. 28 meter. Okay, understood? First part is clear? First part is clear or not? Hello? First part is clear? Am I audible? Okay.